CS majors, we encounter algorithms in the daily. It may not be a confusing concept, but let's break it down. An algorithm is an ambiguous description that makes clear what has to be implemented. For example, in a recipe, an explicit description such as bake until the cheese begins to bubble is not vague. It expects a defined set of inputs and produces a set of outputs. An algorithm is guaranteed to terminate and produce a result.
What if you don't know how to describe your real-world problem? How can you use deep learning, data-driven techniques, modern data-driven techniques to learn that question or something like that? So that's what we're doing, is we're trying to enhance we're trying to use the principles behind the SALSA algorithm, which are proven, they're proven over time and mathematically and so forth. We want to use those principles while also using sort of the power of data-driven techniques. This equation is a very simple way to model some signal. Y on the left-hand side is our signal or our data, and we're just saying, okay, we want to rewrite that into two parts. Like, one is just some noise. Like, we assume our signal has some noise and we don't really want to model that directly. We want to model, the signal itself that we're interested in. And we want to model it in two parts. A is a dictionary, and X is like, which pieces of the dictionary do we want to use? So we're rewriting our signal in terms of a dictionary, and that can help us understand what's in the signal. So like the example is like this. So basically, if you take like a little patch of this image, like this cat ear, you could rewrite that as just like, a sum of 5 different curves, and that's just building on the principle of any shape is a sum of simpler shapes. So instead of, storing all these pixels, like all bazillion pixels that are used to represent this ear, you can just store like, oh, that ear is, 20 different curves. So you're going from like 10,000 pixels to 10 curves. So that's what I mean when I say efficient and I say we want the model to be sparse.
Cocktail party effect is the ability to focus on a single speaker in virtually any environment. Initially, this was Cohen's original problem, but after researching, he realized that it was difficult to find an ultimate solution since there were other problems. SALSA is used for turning some signal into an image. An example in which it would be used is in MRIs to obtain results in a short amount of time. SALSA and LSALSA are fairly similar, but LSALSA is a more useful algorithm for real-world problems, such as Google search engines, to obtain data faster. The algorithm LSALSA is an easier way of approaching to a solution. As seen in the flowchart of LSALSA, the algorithm might be able to solve it faster due to all the possibilities that is put into the algorithm. However, you are sacrificing accuracy but gaining speed. The image of the dog is an example from Cohen's report. It is a representation of sparse coding in which he uses different algorithms to remove the noise from the image back to its initial image of the dog.
Focus on your math, focus on your basic coding skills. Like your goal should be to get to a point where coding is fun. Like you have an idea like, oh, I'm gonna try that and write a little code and make it happen,